So welcome to session 2 for this workshop. So yeah, I hope you were able to follow yesterday and you're ready to progress towards more like slightly more complex scripts today. So I share my screen right now. So we do the same thing as yesterday. So if you have any question during the workshop, you can just unmute and ask because we're a small group, or you can put them in the chat and I answer them as I see them, or anyone else can answer if anyone else sees a question and has the answer, or you can raise your hand with the Zoom feature and I answer. If you have questions, if you think about questions after the workshop, you can always email me. You have my email address on the workshop website, on the slide, and so on. And again, all the material is being put every day, updated every day on the Google Drive, on which we have also the recordings. So welcome to session 2. So today, just a reminder of what we saw yesterday. Yesterday, we briefly saw how the interface is organized, what are the different parts of what you see on your window, on your screen. We saw how just to write and execute command lines and the basic syntax of Matlab, how it works like a calculator, or you can or cannot, how you can and want or sometimes won't use the semicolon and stuff like that. We've seen the different types of variables, so notably numbers and vectors, which are actually matrices, character strings, and the operations you can do with those different variables. And finally, we saw how to work in scripts instead of working in the command window. So to remind you what exactly happened, if I go on my Matlab window, so if you open it today, it might come like that, or you might actually still have maybe things on your command window on your workspace. So if you still have things and you want to clear everything, you can type clear, and that's gonna empty your workspace. And you can also right click, or the equivalent on Mac. Reminder, I'm on Windows, so I'm always using the Windows shortcut, but I'm sure you can easily find the Mac one. You can right click on your command window and click on the clear command window, and that will be clean. If you need to change your working directory, so you don't store MATLAB files everywhere on your computer, you can either do it directly from the address bar or the current folder window. So for instance, if you want to go back to a parent folder, you can click on it here. Or if you want to go in a subfolder, you can click here. Or you can also use the commands cd and then type the address of your directory in which you want to work. And you can check you're in the right one by typing the command cd without any argument in the function. Okay, so that's to start fresh. So I was saying yesterday we finished on how to work with scripts. So so today we really encourage you to work with scripts again, because that's way easier to keep track of your work than if you're working in the command window. Notably to go back and forth between your code and the output if you have to correct something or to save your progress and so on. So if your Windows is the interface is showing this way, you can click on the new script on the top left and you'll have something like that appearing. I remind you that if you want to execute lines, just a few lines. So for instance, I want to just define a new variable that I call word is going to be high. And here when I tap type enter, it's not executing because I'm in the script and not in the command window, so it's storing. And then I'm gonna print that with the function disp. I add a semicolon here, so it's not printed here, but it's only printed here. If I want to run that, I have two options. Either I run the whole script by clicking run here, or I run only those two command lines. On Windows, it's F9, the shortcut to run the selected command window, this command line. So if you're on Mac, you can find the shortcut. I can give you an example of Googling. I was telling you, when you work with programming in general, whether it's Matlab or something else, you're really encouraged to, if you have a question, just look for it on Google. So for instance, here that would be Matlab execute only selected lines. I click on the first link because it looked like it was running well. So F9 is for Windows. So for it looks like for Mac it's Shift F7. So if you want to try that on your Mac, if you're using Mac. Yeah, and another thing I was telling you yesterday that I illustrated here is that Matlab is very explicit in its error messages. So for instance, when I first typed that, I made a typo in the disp function. And so it's clearly saying, I do not recognize that function or variable. So I know there was something wrong with that specific line, that specific word in that line. So I could easily correct it. Okay, so that was what we saw yesterday, and that's where we're gonna start today. So again, I'm a bit of a maniac with my command window and environment, so I'm gonna clear everything. Okay, so for today, we're gonna see the if statements and the for and while loops. So those are two very important structures that will help you generate more complex algorithm that would be very useful if you work with, for instance, big data sets. Some of you are working on imaging or on genomics data, this kind of thing, and you want to repeat some manipulation, some operations, or you want to test some conditions to extract some specific data and so on. That would be this thing that you're going to use. Then we're gonna see a few more things about matrices. And finally, we're gonna see how to create functions, which are also very useful when you have an algorithm that you want to repeat several times, but for instance, apply to different data sets, or just change slightly something between each repetition, like for instance, the value of a parameter in your function. So we'll see that today, and let's start. Again, if you have any questions, just let me know. So the if statements. So what happens when you have a if statement in your code, and why you would sometimes use the if statement is first you're gonna give Matlab a condition that you want to check. So for instance, is number A smaller than number B? And if that condition is true, it's gonna run the code that is just after the if statement. If that condition is not verified, it's gonna skip whatever is in your if statement and keep on with the code, but after that statement. So it's gonna be useful, for instance, if you want to identify some, for instance, if you have a data set with gene expression levels and you want to select all the genes that are highly expressed, you can say check if that gene is expressed more than that threshold and put it aside because I want to store that one, or execute that function on that gene, for instance. I don't know, calculate how much it has increased compared to a value, a previous value, or something like that. If you're working with imaging, I can imagine you use this kind of thing in, for instance, to isolate some pixels that are a certain intensity or color. If you want to, find clusters of blue pixel or whatever, you can also use this kind of statement to say, if my pixel, look at all the pixel, and if my pixel is blue, you keep it in the subsetted dataset or something like that. Okay, so concretely, the way it works in Matlab, the if statement is here. So you can see here we have if, we have the condition that we want to test. So here I have two numerical variables, x1 and x2, in my imaginary scenario that could correspond to level of expression of genes. And here you can see what I'm saying in that statement is if and actually there's we're gonna write it the other way around. That's the max. But if x1 is larger than x2, then the max will be x2. I'm gonna correct that right now so we don't have a. Okay. And then it ends. So yeah, whatever is between if and and will be executed only if that's true. So we can try something like that. So for instance, here I'm gonna write A and B. So here it's very useful to work in the script so it doesn't, you're not annoyed by the fact, I mean, you can peacefully write your or if statement, and then once it's written, you can execute it. So you can see another thing that that Matlab is good at, like to help you again, take you by the end, is it's dealing on its own with indentation. So here you can see everything that's going to be in your if statement will be a tab away from the border of the script. Right now it's okay, cool. But when you actually have lots of loops and statements that can be nested in one another, that's really helpful because you can keep track of which one is opening where and closing where. And also the fact that it puts colors in your script is helpful. Okay, so once I have that, you can again either run by clicking on run, or you can just select and press F9. Okay. Again, if we were in person, I would, I would discuss the results with you, but I don't want to put anyone on the spotlight. But you can see that it didn't disp anything besides just copying what I wrote, and also the max hasn't been defined in my workspace. So for instance, here if I tap max, it's telling me I don't know that that variable. I invite you to think for 10 seconds about what is the case. So the reason why it's max has not been defined is because here that condition wasn't true. A is not bigger than B. So that part of the code was skipped. If I add something here, for instance, this B, and actually I'm gonna run the script instead of. Okay, here if I run the script, so I can also run it by typing just the name of the script. So here is script. You can see max is still not defined, but this B actually happened. It's displaying the value of B. So that's what I was telling you, because this condition is not verified. This wasn't executed, but everything that is after or before was executed. Okay, now if I change the value, so here I put A actually bigger than B, you can see that the max now is defined. And if I type it, we can get the value of A, and B was still displayed because yes, this happened independently of the statement. Is that clear for everyone? Can you give me a thumbs up? I don't see many thumbs. Okay, so one. Okay, a few. Okay. Anyone who isn't giving a thumb up, if anything is unclear, you can let me know in a public or private message in the chat, and I can try to re-explain differently. Okay, so I invite you to, maybe write something like that in your command window and try to play with different structures. So for instance, here you can change and see what happened here. So, okay, to be rigorous, we'll do that. You can add maybe this max, so you can actually see when the max is generated. Sorry, one thing you might want to do, for instance, is to make sure. So that's what I was telling you. It's important to keep your workspace tidy. For instance, okay, here I won't define the minimum as A because that condition is not verified. So if I run it, I won't have. Okay, I did something wrong. I think it's because min is actually a function in Matlab. Okay, or maybe it's because min wasn't defined. Go back to that. Okay, so this works. If I if I change the value again here, okay, so here max will not be updated, but it's still printing because it still exists in my environment. So that can, if you have that kind of thing happening in big algorithm that you're writing, that can really easily lead to mistakes because it will actually reuse a value that you defined before, but is not up to date anymore. So I really recommend, if you have this kind of thing, for instance, to start by clearing max. So you know that any max value that is generated in that last version of the model you're running or the script you're running. So when I execute those lines, max disappear, and then any new value of max that is generated is gonna come. So okay, I think it's just not working because max is not defined here. So what you could do is actually put that here. So it's gonna display only if it exists. Okay, I hope that's clear for everyone. If not, again, ask me questions. Just to make things a little bit cleaner, I'm gonna use like a script that makes a little bit more sense. So I'm gonna take the script that you have actually on the that you will have on the drive. So I take that's the same one that is in the example on the PowerPoint. Okay, so I take that. I offer you as an exercise, if you go back to the script when you work later, so you can see here that x1 is lower than x2. So when I give that condition, this will not be executed. So think about ways you can modify the code to make it actually print something, because here it's not going to print anything because all the action is happening between the if and end. So that's actually what we already did, but when you go back to the slides to work on the workshop content, that's the way you can think about it. Okay, there are that was, the first element of if statements. We can make them more refined by, instead of having just one true condition and in which the code happened and the other one in which nothing happened, you can actually define more condition than just one. So one thing you can do is use the else statement, which will actually allows you to write a piece of code that will be executed if your first statement wasn't true. So before, what was happening is, if your condition was false, the code was skipped. Here you can provide a piece of code that will actually be run as an alternative to the what is in the in the if statement. So the way it works is, so you can see here it's the same way. If, and I give the condition I want to test. If this is true, then that's run. If this is not true, then this is run. So I can give you the example. I have it here. Yeah, so you can see if that statement is true, this is going to be run, and this one is not. I let you look at the lines a few seconds and try to guess what's gonna happen in the command window when I execute that part of the script. So is x1 larger than x2? No, because of the value I gave. So in theory, we should have the value of max being set as x2, and because I didn't put any semicolon here, it should print max equal and the value of x2. Okay, max equal 500, so that's the value of x2. So I don't know if you noticed, but I didn't put a semicolon in lots of places here, and Matlab is really not happy about it. It's suggesting that I should really put a semicolon. So again, if you follow that, for instance, if I update it right now, and then I still want the value to be displayed when I work, so I can keep track of what is the new value of max. I can add the this max and I run that. And here it's just displaying the value without without writing max equal. So that's a bit more compact. Okay. Is that clear for everyone? Give me some depth. Okay, great. Okay, now there might be situations where you actually have more than just one condition. And in that case, you can use the else if statement. So here, what's going to happen is you define your first condition. It is going to be test, and if that condition is false, then it's going to test the second condition you give. If it's false, it's going to test the third, and so on, as many as you want. And then you can give an alternative for the case where everything else was false. Okay, I have a question in the chat asking about how to open the editor window. So in theory, if you, I'm not sure exactly how it looks on your screen, but if you have something like that with just the command window, if you click on new script at the top left on the plus, so the big plus for new and scripts, that should automatically open this. So then you can type whatever you want. Does that work? Okay, it worked. Okay. Yeah, hopefully you will have it working for that so far. Okay, I'm reopening whatever I had open. So everything I had saved is here. If you didn't save, it should ask you, do you want to save before you close? But yeah, okay. Okay, so now looking at the elf is. Okay, so I'm gonna copy that here. Okay, so again, what's happening? It compares the first condition. If it's true, it runs this, and then it goes straight to the end. If it's not true, then it looks at the else if, and you can again put as much as needed. So I'm gonna clear the window so we can keep track of what happens. Here again, I didn't really put any semicolons, so Matlab is not happy about it, but at least it's gonna print the max value whenever it's generated. I'm gonna again clear my environment to make sure any value we see is actually a new one. I run. Here we have max equal 500. One thing you can do, because we just have that, we don't really know which one was verified. Actually, it was this one. One thing you can do is, for instance, add some text that would say something like that. So you can keep track of which one was executed. Here you can see third condition was true. I was telling you, it stops going through the condition that as soon as it encounters the first one. So for instance, here, if I put 600, obviously now it's going to be the first condition that is true. So that's what we have here. But if I, for instance, if I add, I had a third one that will also be true. So for instance, I will put the same one. So now it becomes the third. And this one is the fourth. You can see it only printed the first condition is true, although the third was also true. But because it already encountered the right one, it executed this. And as soon as this was executed, then it jumped to the end of the script. So if I put something here, you see that this is still executed. So it stops executing whatever is before the end, but it will execute whatever is after the end. You can put as many else if as you want. It's always good to have an else at some point, just to make sure that something happens, even if none of the condition was verified before. So for instance, it can be, setting a value to 0, or can be saying none of the conditions were true or something like that. Just to make sure that your code runs, because otherwise if you execute an if statement with none of the conditions true, then nothing is gonna happen. And you might, just have doubt that it was actually run correctly. So I encourage having something like that, always a else statement at the end that is supposed to do something, so you can check it actually run. Okay, so when you look at the diagram like that, it looks a bit complicated, but it's yeah, if you really look step by step, it's not that complicated. So again, if the first statement is check, if it's true, it runs the if code and then it goes to the end. If it's false, it checks the else if condition. If that condition is true, it runs and goes to the end. If it's false, it runs the else code, and you can add as many else as you need. Okay, is that everything clear? If you have any question on if statement, let me know. Otherwise, we move to for and while loops. Okay, I don't see any questions. So moving to for and while loops. So I start with the while loops, even if they're not that common. People don't use them that much, just because they're close to if statement. So that's an easy transition. So here, what's gonna happen is we check a condition that is in the while definition, in the definition of the while statement. If that condition is true, then it will run whatever is in the while code, and then go again at the beginning of your statement and check if that condition is still true and run as long as that condition is true. So you might already have a clue of why we tend to avoid using those while statements if we can. It's because sometimes if we have a mistake in our code or we didn't expect one specific conditions, we can get stuck in infinite while loops that never stop because our condition is always true. Your loop will only stop when your conditions become false. So to give you an example, here I define the value AA. As long as AA is below 20, so I put that at the threshold, it will display AA. And okay, if I just write that, it will keep on displaying AA because AA is 10, so AA is always below 20. But you have to do something that is changing. So so there's actually a need that for you to check whether your condition is still true. So for instance, here I put at each iteration, AA will increase by 1. So I'm incrementing AA by 1. So if I write that in my window, so I remove that one. Again, I clear everything. So I put A equal 10. I have my while statement. So it's the same structure as if. So while, then I put the condition that I want to test between parentheses. Then I run the code that I want to be executed if that condition is true. So here it's if AA. Then I don't forget to have something changing so we're sure that we don't get stuck in an infinite loop. So here I put AA plus 1. When you're working with actual data, typically the kind of thing you would have is, for instance, look at all the columns in the table. For instance, I don't know, if you want to store the 10 first values that are positive, that are above a threshold in your data set, you can say, you can ask Matlab to look at the row one by one and store as long as you haven't stored 10 yet or something like that. Okay, here I'm gonna add a semicolon here to make sure that I don't display that value of AA, but only this one. And when I run this, you can see it runs. So it starts with AA equal 10. I run display 10. Then next so then it increase AA by 1. It check if is that still true. That's still true because now AA 11, so it displays it. Then it adds 1. Is it still true that it's below 20? Yes, so it goes to 12 and so on until 19. Let you think for a few seconds, what can I do if I want 20 to be displayed in that script? So you can think, you can try in your own code. You can put the answer in the chat if you want, but again, I don't want to put the spotlight on anyone. Here, if I put AA smaller or equal to 20, now it prints 20. if I put a condition that is false since the beginning, then it doesn't display anything. There are a few things you have to be careful with while loop. So I already told you a few times you have to do the incrementation or whatever condition is changing in your script within the loop. You have to do that, otherwise you get stuck in an infinite loop and you have to stop the execution. The other thing you absolutely have to do is define your the index on which you're looping. So here is AA before the while loop, because it's the while loop is straight gonna start by testing what is your condition. So here, like, what is the index, whether the index is below 20. So you need to have that defined before. If I don't have AA defined before and I just run try to run this, I'm gonna have an error saying I don't know AA. So don't forget to have that defined before. Another thing is if you work with command window, so for instance, okay, here I don't have AA. I define AA as 10. So if I run this, it's gonna work because it knows about AA. But if I try to run it again, then it's not executing anything because AA kept the last value it was given, and that was 20 in the loop. So that's why a good practice is to always define your index variable just before the loop, so you make sure you start with whatever you want to start with. Okay, so the two important things: define your index variable before the loop and increment your index variable within the loop. Declare the index, increment the index. Okay. So if you want to make it print up to 20, you can just change to less or equal instead of just smaller than. And if we want to, make it a little bit fancier, have a nicer output, instead of just displaying AA, we can, for instance, use the fprintf function that allows us to print character strings. Here, because we're calling a value that is defined before, we put a %d because we're calling a double, so you can check what the class of A is with a function class. You see it's a double, so that's %d. That's stuff we saw yesterday. Okay, then that should work. I'm just gonna add this so we don't have one big sentence. We actually have a statement at each line, like an output at each line. Okay. Right now it's just to make like clean sentence, but it's going to be useful, for instance, if you decide to store data as a CSV or tab delimited files, because you can then just add commas to separate values or things like that. Okay, so that was the while loops. Another thing that is very close to a while loop, that in most cases you can actually replace your while loops by for loops, and for loops are a bit simpler to write, and I'll explain right now why. And again, we don't have that issue of like risking to get stuck in infinite loops, because what happened with for loops is that the index is declared and incremented straight away in your for statement. So for instance, here when I write bb equal 10 to 19, I'm saying that first BB is going to be equal to 10, then it's going to do the incrementation in the loop. So it's going to do, because here I just wrote it like that, it's going to do 10, 11, 12, 13, and so on until 19. And that's happening in the loop. I don't have to write it here. So you get the same result. So for instance, I write the exact same thing, but with a for loop. So we said it's 10 to 19. And if I run this, you can see it printed the AA and then the BB. And so you have the same thing, but in 3 lines instead of 5. And you don't have that risk of being stuck in an infinite loop. So if you can use a for loop, which in most of the case it's going to be true. The only case where you're not sure, where you might want you still want to use a while loop is that if you're not sure how many values you're gonna, like you don't know in advance which value BB should take. Then you can use, in any other case you can use a for loop. So again, that's the main difference. That's the thing you have to keep in mind. If you use a while loop, declare the index and do the incrementation. If you use a for loop, you don't have to do it. It's happening in the loop execution. Here, just to make it clear, when I write this, what Matlab is doing is generating a vector that goes from 10 to 19 one by one. Yesterday, I told you can change the step size. Instead of being 1 by 1, it could be like 2 by 2, for instance. And I didn't remember how, so I Googled it, and I think it's actually like that. So you can put the step size between 2 column symbols in your definition of the vector. So for instance, here, if I do it that way, and I'm just gonna keep that one, you see we have 10, 12, and so on until 9. You can also do it with decimal numbers if you want, and so on. If you want to do it with a vector that is not following a regular increase, like it doesn't have a regular step size, you can also define the vector yourself. So for instance, if I want to do something like 10, 14, 10, 13, 14, 18, 19. It does that. So for instance, if you already have a vector defined somewhere and you want to use the values that are in those vector, in that vector, you can just call your vector instead of, you don't have to generate the value within the loop. You can have the values already stored somewhere. So again, that's going to be useful if you already have, yes, for instance, if you're going through a table and you want to say for each of my individual data points that I have, for instance, if you're working on samples, you can say, okay, for each of my individual sample, I want you to store that value. You can just say to Matlab, look for whatever value are your samples on. Yeah, so that's just to say here, it doesn't have to be from 1 to 10, 1 by 1. It can be more or less anything you want maybe to take. Okay, is that clear for everyone? Give me a thumbs up if that's the case. Otherwise, ask question in the chat. Okay, great. Didn't see thumbs up for everyone, so I just hope it's because you couldn't find the emoticon right now. But if you have any question, just really put them in the chat. Yeah, it's very useful when again, either you want to look at different things in your table and go like row after row, or if you want to simulate processes over time. So for instance, if you want to you know, say for instance you simulate the population growth, like the growth of a population of bacteria, you can say there are that many bacteria at the beginning, and for each time step, so time 1, time 2, time so on, then the population increased or decreased by whatever function you defined before. And yeah, you can, it's gonna repeat the calculation over and over again for the time step you predefine. Okay, so here what I did is just to show you, you don't have to have only one statement in your, or one action in your for or while statement. You can have more complicated things. Notably here, instead of defining just AA or just BB, I can put both in the same. So if I, so how, well, okay, I'm gonna copy that script and we're gonna discuss together what it does. Okay, so here, okay, I didn't take the AA equal 10. Okay, we have AA equal 10, BB equal 10. Then we say for each value of AA, if it's below 20, then you execute everything that is here. So the condition is on AA, but some actions are on BB, and that's perfectly fine. You can put anything you want in your within the loop. It's gonna print the value of AA, and then it's gonna increment AA. It's also gonna print the value of BB and execute a function on BB. So here, instead of just incrementing by 1, I decided to multiply by 2. And that's going to do this until AA reaches 20. So if I run this, okay, you can see AA goes from 10 to 20, and BB does whatever BB has to do, because BB is not included in the conditional statement. So there is no condition on BB. Is that clear for everyone? No question? There's something that you might want to use just as a safe wording in your while loop. So I said you can be stuck sometimes in infinite loops or just in loops that last for longer than you were expecting. You can use a break statement. So the break statement will terminate the loop independently of what was said in the while condition. So for instance, here I'm saying when BB reaches 5,000, you break, and maybe the while loop was still planning to run. So we can look which value we had. See, the while loop is expecting to run below beyond BB equal 5,000. But if I add a break, so I put if BB below 5,000, above 5,000, then break. Sorry, it's on window. And that's gonna terminate the loop independently of whatever the loop was originally asking for. So we can try that. I'm gonna clear again so it's clean. And you can see here the loop stops before AA reached 20 because BB reached that threshold that we define here. So again, that's useful when you don't know in advance, which condition is gonna be true first, or you just don't really know in advance how your numbers will behave. If you want to take 5 minutes to try to print AA and BB in the same statement, so you can use the fprintf function, and instead of having them in different, like in 2 different statements, you can make a sentence with both of them. I give you like, maybe 5 minutes to try to do that. Just so you can first write this code if you haven't already. That will, put in your mind things like don't forget the semicolons or put the parentheses across the state. Around the condition you want to test and so on. You can or cannot, but you won't. You don't have to put the comments. They're just here to help you understand what I did. And so you can try to do that, and and try to have both printed in the same statement as just so you don't just copy what I wrote. I give you 5 minutes to do that, so I check again on you at 10:32. Okay. If you have any question in the meantime, put them in the chat. So we have answers coming in the chat, so well done. I don't know if you tried to run it, Ricardo, as you posted it, but indeed that's it should work. So you can see if you all open the chat, you see the answer Ricardo proposed. So you just have to have one fprint statement instead of 2, in which you put a sentence with AA and BB, and then you have to put the 2 times the person D, and the first one will be given the first following argument. So here it's AA, and the second one will be given the second argument. So that's BB, the way it was written. He didn't put the definition of AA in BB before, but I assume that's just because they were already written in his script, so he didn't need to put them again. But yeah, don't forget when you put a while loop to always declare your index variable before you start running the loop. Okay, so we move on. Nice to see that you're following enough to be able to run your own small script. So what happened with the break statement that I was showing you just before? So the while loop will run, as I was saying before. If the condition is true, then it runs whatever is there. I put an if statement in the while statement, and if that condition is true, then it runs the break code that was in my if statement. So you can see if I go back, the break here is in the if. So if that's true, it's gonna break, and whatever was in the while code will be ignored, because now the Matlab will just break the execution of the loop and go straight to the end. So it's the equivalent as if the while condition was false, even if it's still true. Okay, so we just saw that you can put an if statement within a loop. You can also put several loops within one another. So that's why I was telling you that it's very useful and helpful that Matlab is doing managing the indentation for us automatically, because we can see, for instance, that this n here is closing this loop here, and this n here is closing this one. So they're really nested in one another. So it's not the first n close the first four and the second n close the second four. It's the first n close the last four, and so on. And you can really keep track of that with indentation. So here, for instance, that's useful if you want to define a grid. So for instance, AA will be the position on the row, and BB the position on the column, or something like that. So here what's gonna happen is that AA will go from 1 to 10. So AA will start at 1. When AA is 1, BB will go from 1 to 10. So we will have AA equal 1 and BB equal 1, AA equal 1, BB equal 2, and so on until AA equal 1 and BB equal 10. Then it's gonna, this loop is done. So it's gonna go back to the beginning of the first loop. So AA will go now to 2. So we have AA equal 2, BB equal 1, AA equal 2, BB equal 2, and so on until AA equal 2 and BB equal 10. And so on until the end where AA equal 10 and BB equal 10. So we can also run that. So I take what I already written so you don't look at me type for 5 minutes. Okay, so again, it's gonna go from EA equal 1 to 10, and within which value of AA, BB equal 1 to 10. So if I run that, so here I put that at the beginning just in case, you know, we don't clear the command window, we still have a clear break where simulation is starting. That's lots of value. Okay, so it's starting here. So you can see AA from 1, I mean, BB goes from 1 to 10 within AA equal 1, then BB goes from 1 to 10 within AA equal 2, and so on. And you can have as many loops as you need. So if you need to add 15 loops within one another, if you are doing a 15 dimension grid, for instance, that's gonna work the same way. And so every time I add a new for statement, Matlab will do the indentation with me. So okay, here's so what here. So for instance, if I write anything new here, you see it's indented, and then when I close it, it's aligning it with wherever the loop was starting. Yeah, so I know that can be, you know, scary when you start to have too many for loops, but it's really just, you know, take the time to really understand one by one what they're doing. I mentioned that later, but often it's very useful to write what we call a pseudocode, which is the, you know, writing with words what is happening. So if you just take a notebook and you know, you look one by one what's happening. So the first element that will vary is the one in the final, like in the most nested, in the deepest loop. So you know that BB will go from 1 to 10, and then that's going to be repeated for AA equal 1 to 10. So yeah, you can just, you know, try to predict on a notebook whatever is going to happen. And really, if you take, you know, 30 seconds, 5 minutes to think about it, it's not as overwhelming as it might look at the first look. Okay, what time is it? It's 10:30, so I suggest we maybe take a break now. I think that's a good point before we move to more matrices. So is that okay for everyone to take a break? If you don't want to take a break, just put something in the chat. Okay. It looks like tomorrow was a bit optimistic about the time, so maybe today we can take just a 10-minute break, and then if you have more time, we'll either take another break later or finish earlier. So it's 10:39, so we meet at 10:50. Okay, I see you at 10:50.
MND?
Yeah.
Really quick, what was the result of your last script?
Yeah.
I didn't see what it was on your screen.
Sorry. I'm gonna share my screen again. No, share.
Confirm.
Yeah. So for the one with the disp CC. Well, so this was the one with just AA and BB.
Yeah.
So you can see it's doing, first it's moving on BB within AA. So BB goes from 1 to 10 within AA equal 1. And then it's moving to AA equal 2.
Got it.
And it does it again and so on.
Yeah, that's what I got.
Okay.
Okay.
And if I print that, it's just gonna print 10 times the same thing with CC in addition. That's gonna be lots of line. That's why I didn't write. Okay.
Okay. Thanks.
Great. Okay, so I'm gonna share my screen again. So I didn't receive any question during the break, so I hope that means you're confident with comfortable with the if and if statements and for while loops. As usual, I really encourage you to send me any question that you might have later, even if it's afterward, no worries. Okay, so now we're gonna go back to working with matrices a little bit more, just because that's like the main object we handle in MATLAB. Yeah, that's really the object around which MATLAB was built, and most of the data we handle or generate are in the shape of a matrix. So one thing that can be useful is being able to modify or call the specific element within a matrix. So again, I remind you that I'm talking about matrices in general. Sometimes I actually use vectors or numbers, but that's because in MATLAB, a number or a vector is actually a matrix, in a sense that a number is a 1-by-1 matrix, a vector is a 1 by x matrix or x by 1 matrix, depending on whether it's a row or a column vector. And then a matrix is a x by y matrix. And also, again, I remind you that you can actually go with more than 2 dimensions in your matrices, and we'll talk about that in the coming minutes. Okay, so for instance, here I define a vector that goes from 4 to 9. I remind you that when you put commas, you are putting elements side by side, so that's a row vector. They're all side by side. If I had put semicolon, that would be at the top of one another, because a semicolon means that's the end of the line, go to next line. So that would be, if I had put semicolon instead of commas, that would be a column vector. So here I have a row vector or 1 by 5 matrix. You can actually check that using the size function. So I'll show you again. As usual, I will clear everything before moving on. Okay, I'm gonna do like I was doing before, which is writing in the script and then executing using F9, just so I can more, like keep track more easily of what I'm writing. So I define my vector. So a reminder, you define vectors using or matrices using the square brackets. So I did 4, 5. Not that I wrote it that way, but I could also have written it that way. That would give the same result. By default, this is a step of 1. So you can, yeah, we can check that. Keep that here. Okay, and if I use that notation, then I have the same thing, except that I forgot the 8 here. Okay. Okay, so when you have something something like that, and you want, for instance, to call the element that is at the first position, you can use a parenthesis. So if I put my vector parenthesis 1, I execute that, it's gonna tell me on the first position you have a 4. If I use the same thing but with for instance position 5, then it's returning 8. So that's you know, pretty straightforward. You can also, instead of just calling one element in your vector, you can call several ones at the same time. So for instance, if I use just the colon, that will call all the elements. You can see here it's not a vector anymore. It's like it's it doesn't keep the dimension of your vector. So for instance, if I had a matrix, I would just put them on one column. Here I'm calling positions 2 to 4. Here, I don't know if you remember, I talked about the length function before. So it's to be not mixed up with the size function. So the size function here will return the dimension of my matrix, which here is 1 by 6. The length function is gonna return only the largest dimension of my matrix. So here it's gonna be 6. And so if you're working with a vector and you want to call all the elements that are between position 2 up to the end, you can use the same notation that we used here, but instead of just 1, your first element is going to be 2, and you're going to call all the position until the last one. And the last one is, by definition, the length of your vector. So if I run this, I have all the elements of my vector except the first one. So I'm missing the 4 here. And again, I can show you here. I'm gonna call all the elements one by one and so on. If I have a matrix, so I just do the same thing. I'm gonna do okay, here I define this matrix. I guess I can call it my matrix. Oops. Okay, so now we have this matrix. If I call all the elements of the matrix with just the column, you see they are all called, and they're not as a matrix anymore. They're just in a list in a row in a column vector. And again, I remind you that Matlab, the way Matlab goes through matrices is first looking the first row, So here that's 4, then 14. Then the second row, goes across rows in the first column. So first column 4, 14, then the second column 5, 15, 6, 16, and so on. Again, that's something I always forget in which way it goes because it depends on the programming language you're using. So I just recommend when you start working on a code that is using that kind of features, just check before you run it on big data sets that it's doing what you think it's doing. And so I told you before, I don't know if you remember, that Matlab has this way of, if we were looking, we were using the find function, which was looking for non-zero elements in a matrix. And instead of returning the 2 coordinates of the elements in the matrix, it was just return 1 position. So here I can use the same feature. So for instance, if I want to call the, I want to call this element 16, I can do it 2 different ways. I can do it the way I think is more intuitive for us, which is calling the 2 positions. So it's going to be on the second row and third column. So if I do 2, 3, that should return 16. Okay, that works. But you can also do it as calling just the element on position 1, 2, 3, 4, 5, 6, position 6. It's actually the way it appears here, position 6. So if I do my matrix and 6, I have 16 too. So that's just, you have these 2 ways to find or to call the element in your matrix. You can also use the same notation to change an element in your matrix. So for instance, if I don't want this to be 16 anymore, but I want it to be 26, I can just write it that way. And now if I check my matrix, you see in position 6 or in position 2, 3, the 16 has been changed for 26. So that's what we saw here. You can call the elements of your matrix using their coordinates. So the first dimension, or what the row first and then the column. You can also use this kind of notations to call, for instance, the first row. So that's going to be the first row, and then every element on this first row, or the first column. So every element on the column that is at position 1. Yeah, you can also, if you want to generate matrices yourself, something that can also be useful. Here I was, putting random numbers, but if you want to generate matrices just of zeros and one, which are useful in lots of cases where, lots of time we just want to use a diagonal of a matrix, so we start with a matrix of just zeros or just ones, and then just change the diagonal. So you can use the function zeros, and then you put a number that's gonna correspond to, if you put only one number, by default, it's gonna generate a square matrix with 2 dimensions, and those 2 dimensions would be of length of that number. So here I have a 4x4 matrix of zeros. I can do the same thing with 1. You can do the same thing, but not having a square matrix, but having 2 different values for your 2 dimensions. So for instance, I can do a 2x3. I have a 2x3. And as I was showing you before, you can change individual values. So for instance, I generate a 2x3 matrix of 1s, but now I'm saying I want actually the first column, the first row to be equal to 0. So I do 1, so the first row is going to be 1, and then all the row, and I put it to 0. Okay, so that's I think pretty intuitive the way MATLAB works for that. And I was mentioning just before, you are not limited to two dimensions in MATLAB. You can actually generate matrices of 3 or more dimensions. So for instance, I'm gonna do a 3x4x2. So 3x4, that means I'm gonna have 3 rows and 4 columns, and I'm gonna have 2 what in the MATLAB vocabulary we call pages. And so when you execute that, because obviously we cannot just see 3D structures with just in the command window, it's gonna be printing first the first page and then the second page. So that's how it works. And you can call elements the same way as we were doing before. So for instance, so here they're all equal to 1. So I'm just gonna change 1. So first I define, just so it's simpler, I can use my matrix instead of nths. And then I say, okay, I want the first element on the second page to actually be a 3. So it's gonna be position 1, 1, 2. And I want it equal to 3. And now if I check again my matrix, what it looks like, here you have a 3. So on the first position, first row, first column of the second page, it became a 3. Okay, is that clear for everyone? If there's any question, let me know. Otherwise, I keep moving on. Another thing that can be useful when you're working with data is sorting the values. And to do that, we use a sort function. So for instance, if I have, I will take again I guess I will take my vector here, but I'm gonna make something that is not ordered. So 3, 1, 8. Okay, so I have this new vector here. And if I use a sort function, I have a sorted vector. You can, for instance, use that to define a new vector that is sorted. You can also order elements on your matrices. So for instance, here I had, this second page of my matrix. If I want to have the 3 at the end, I can sort it. And so the way it works, you put the matrix you want to work on, and then which elements, which elements you want to order. Yeah, so which dimension? So you can see here it moved to the end of the at the end of the first column, so through the rows. If I do it on the other dimension, it goes at the end of the first row. So it sorted the columns. So you can see here, I'm actually treating the page 2 of my matrix as a 2D matrix. Okay, now we're gonna move to cell arrays, which is actually, it's kind of like matrices, but they're a little bit more flexible. But for lots of things, they work like matrices. They're very useful when you work with character strings, because it can be a bit of a mess when you have when you handle character strings in Matlab. And I show you an example. So for instance, if I define some text, I guess I wrote, my name and my family name, and I want to check whether those are equal. Sorry, I forgot. You have to put 2 equals. So first, it actually doesn't work with characters. What is the thing I was trying to do before? Yeah, is so okay. What happened is that when you have several elements on the in a matrix that are character strings, like for instance, I have here. Matlab will see every character as an element on its own instead of this being 3 different things. So the consequence that if you look at it, it's gonna merge them. And so what I was trying to show you, but I was using the wrong function, is when you try to compare 2 different strings that are in a matrix, actually Matlab struggles because it's looking at character by character instead of comparing the strings together. And so for instance, here, what I tried to do, if I generate a matrix with 3 strings side by side, it works fine. But if I try to put them as a column vector, so at the top of one another, it's not working. You have this kind of error because so it says the dimension of the arrays being concatenated are not consistent because the size of those is not the same. So, okay, if I do it here, for instance, if I try to generate a matrix with my first name and my last name, it works, but you can see it's merging it together. And if I try to put them at the top of one another, it doesn't work because they are not the same size. And if I add a few letters, maybe I had too much, then it works. I like this. It's really an issue with the number of characters. Okay, so the way to avoid that, because very often you will have to work with strings in your data sets, they are the name of the individual, the site, the genes, or whatever, is to work with set arrays. So set arrays work like matrices for most of it, except for that. And the way to make a difference between a matrix and a set array is, you remember a matrix was defined using square brackets. Set arrays are defined using those curved brackets. So for instance, here, if I try again with the curved brackets, you can see I have it's indeed storing those 2 elements separately instead of putting them, like concatenating them together. And if I try to put them at the top of one another, it works. So instead of considering that this was a 8 element matrix and this was a 6 element matrix, it's considered this is the 1 element that is 1 string of characters, and this is another element that is 1 string of characters. So there is no dimension issue anymore. You see the difference? Is that clear? Okay, perfect. So yeah, again, the difference between matrix and set arrays are, when you define them, is using square or curved brackets. And the main situation in which you want to use set arrays instead of matrices is when you're handling character strings. You can generate set arrays with the function cell, like I use here, and we'll see what it gives. And so another good thing with cell array is that you can actually mix within a cell array variables of or values of from different class. So you, for instance, we see now you can have strings and numbers within the same. So I'm gonna create one called my cell, and I put a 2x3 cell array. So again, it works like a matrix here. So it's you're giving the dimensions. And so you can see by default it's creating this empty cell array that is 2x3 and is kind of waiting for numbers. So here it's saying I have a null dimension number or matrix in here. And then you can assign values. So for instance, I'm gonna change the value of the first row. And I'm gonna put names and stuff. I'm just gonna use this one that I had pre-written. Okay, now you have something like that. So I said the first row should be equal to that array of a dimension 1x3, and so it changed it for it. And so you can see here in the workspace, or you can also look by using the class function that's called the class here is cell instead of double. So double is for matrices and everything related to numbers, vector, and so on. And cell is for cell arrays. And you can see already here that we're mixing different types because here we have character string and here we can put numbers. So for instance, I probably have numbers. Yeah. If I use that one now, and then I look at my cells. Oops, I put on this. Okay, but make sure here we have character string and here we have matrices. So they are 1x1 matrices, but they are matrices, so numbers. Now you have to be careful when you use those cell arrays about when to use the parentheses or when to use the brackets. When you are using the parentheses, as we were doing before, when we were using calling elements within a matrix, for instance, we're gonna call the cells. So for instance, if I look at my cell and I want to look at the first row, I'm looking at the cells. If I look only at the first one, I'm calling the cell here that is on the first position. If I use the brackets instead of the parentheses, I'm calling the value that is within the cell. So just sometimes you might have errors when you are running scripts that is saying something is not the right dimension or is not the right type. That might be because you use the parentheses instead of the brackets or the other way around. So just a warning there. Yeah, so you can check that by, if you use class on something you call with parentheses, it will tell you that's a cell. And if you use class on something you call using the brackets, it will tell you it's either a double or a car, depending on whether it was a matrix number or whether it was or if it was a string. Okay, so now we're gonna mix everything we've learned so far together. So just checking, is everyone all right? You're keeping track of what's happening? No question? Okay. Again, if there are questions, don't be shy, put them in the chat. Okay, so let's imagine that scenario. So we have a set of genes. I am not a person working on genomics at all, but I thought that was the example that would work the best for you. So I recycled the example that previous instructor we're using with genes and expression levels. So we have a set of genes and their expression levels, and we want to know the name and the levels of expression of genes that are expressed above a certain threshold. So that's where I encourage you to think in terms of pseudocode before starting writing. So imagine you have a data set, so we can actually use that, that cute little cell array we generated. So I'm gonna clear everything and just keep that one. Okay, I'm gonna go in the script, so it's gonna be a bit easier. I'm gonna clear that too, and I run that. Okay, so we have that cell array. So imagine you have those 3 genes. Here are their name, and there are 3 levels of expression here. So we want to find the genes that are expressed above a certain level of expression. So what we're gonna do is we're gonna look at each gene one by one. So usually when you think one by one or one after the other, it means that you're gonna have to lose a for loop. Then we're gonna compare its level of expression to a threshold. So here we're comparing something, it means we're gonna have to use an if statement to see, is the value above or below the threshold. And then we're gonna display the one that have the higher level of expression compared to the threshold. So what I just said, that we need to have a for loop within which we have an if statement, and in this if statement we're gonna use the disp or fprintf function. So that's what we call the pseudocode, where you are already pre-coding in your mind, but just with words instead of command lines. So for loop, if statement, and fprintf. Okay, so instead of working with a cell array, we're gonna just, for instance, call that's gonna be gene names, and here that's gonna be gene X. Okay, so I'm actually not using the cell array. So I define those 2. Then I'm gonna look at them one by one. So I don't remember how I coded originally, but here you have 2 options. Either you already know you have 3 genes, so you can go from 1 to 3, or you don't know how many genes you have too many of them. You can use the length of gene names. You can check that's actually what you actually want by just, if I run that. Okay, I forgot to define that first. Okay, that's 3. So that's gonna go from 1 to 3. You do whatever works best for you, but in my case, I like to, every time I open a new loop or statement, I like to close it and then write in between. So it's easier for me to make sure that I close everyone, even if Matlab is already helping me with the indentation and so on. So for each one of these genes, I'm gonna compare. So I use an if statement, its level of expression. So it's gonna be gene X to the threshold. So I'm looking for a threshold. So here there are several things I need to solve. So the first one is I need to define an index. So I'm gonna use II. So the reason why I use II and what I was using AA or BB before instead of just using I is because if you decide to change the name of the index, for instance, if you start having 5 nested loops and you don't want to call them with II anymore, and you want to actually call them with a name that is more explicit, so for instance call for column or something like that, and this way you can just use the find and replace function and look for II and replace, for instance, for I don't know, gene number or whatever. If you just use I, you cannot do that because there will be I everywhere in your code. While the I is a bit rarer. So anyway, I define my index I, and so now I need to say I want to look at the gen expression that is at the position I. So here I want to compare a number. So what I want is the value within the cell. So it's going to be this. Hopefully I'm not wrong. And you see, I also need to define the threshold. Here it's here, but I haven't defined it before. So I'm going to define it here as, for instance, we'll say 500. That's going to be a threshold. Okay, so if that's true, so again, I close my statement before putting anything in there. I'm gonna print the value, the name and the level of expression of that gene. So it's gonna be f print f, and I'm gonna just put something like that. So here I'm gonna have a string, and here I'm gonna have a number. And so the first thing I call is the gene name actually, the one that is on position II. And the second thing I'm calling is the expression level. Okay, and we see if that runs. I usually make typos everywhere. I might have messed up with parentheses or brackets somewhere, so we might have errors, but we'll see. Okay, no, it's working. Okay, so here is an example of mixing set arrays, for loops and if statement. Is it clear for everyone? Okay. So moving on to the next thing. Yeah, before I was trying to compare strings with the equal, and that wasn't working. The way to do it in Matlab is using the string comp function, so str comp function. So instead of writing, name or string 1 equal string 2, you have to write string comp for string comparison, and the first value and the second value. So for instance, here, that's if I'm looking for a specific gene in my data set. So I'm just gonna add this because it's bothering me. Okay. So I'm gonna add a second one, but this time, instead of looking for specific values of expression of the level of expression of the gene, I'm looking for a specific gene. So for instance, I called it gene of interest, and I'm gonna use that. Let's use another one. I'm gonna use that one. And so here I'm gonna compare. So this time I'm looking at the name. So same at the position II, and I'm comparing to the gene of interest. And okay, I made a mistake, so I probably made a typo in the. Okay, so yeah, there is no O actually. It's. Okay, and so I have the level of expression from the for loop. And so the one that is above the threshold, and from the second loop, so the one that is the gene I was interested in. You can actually put both within the same loop, because you see that they're looping on exactly the same thing. So they're just looking at all the genes one by one. So I can put them in the same loop. Here, I don't need to use if and else if and so on, because I'm actually looking like it's two tests that are independent from one another. That could be the same gene or not. If you use if and else if and so on, the issue is that as soon as this condition is verified, it's not going to look for the other thing. So here you want to check both conditions independently. So you need to use if and then another if and. And you see you have the same result. Okay, I'm going to just correct that so it doesn't stick around. And okay, so that's also the occasion to yeah, that's what I was trying to do before. Okay, that's also the occasion to introduce a new type of variable, a new class of variable, which are logical. So logicals are when you do a logical test. So you know, the kind of test where you expect the answer to be true or false. So it's like a Boolean in probabilities or something like that. So for instance, if I look here, okay, I'm gonna just look at the, instead of, I am just gonna look at the first one. So the first gene is this one, 1L, 1A, and has a value, a level of expression of 120, which is below the threshold. So when I run this, it's returning a logical 0, which means the answer is no, or the answer is false. And here, it's the same thing that's happening. So if I put 1, it's gonna also return no. However, if I put 2, that's the right gene. So here the answer is 1. So that's what's happening under the hood in those if statements. So yeah, here what you can see is what I was trying to do before. I don't know where it didn't work out. I must have made a typo somewhere. But if I try to compare those two character strings, instead of just checking whether the one is equal to that one, is comparing letter by letter. So here I have a nice, yes, that's the same. The answer is yes. While here I have 4 answers for the 4 letters. I think that actually the issue, what I did before when I used my first name and last name, was probably that because they were not the same dimension, some of the letters had nothing to be compared with. Okay, so we just done that. Yeah, so what I was illustrating here is that you see how here I just write if this condition, and what Matlab is doing is running that only if this is true, so returning 1. But you can actually, if you want, you can change it. So you can either write it explicitly, so you want this condition to be true, and then it's gonna run that, or you want this condition to be false, in which case it's gonna run this for all the other genes than the one you are looking for, or the one you indicated. So that's the way to say, I wanna check, I wanna print everything but that value. Okay, and so now we're gonna move to the last part, which is functions. So before we move to functions, just want to check again, is everything clear so far? Because with the functions, we're gonna use like reuse things we've written so far. So it's gonna be working better if you. Okay. Okay, so I have a question. Okay, so I'm asked to go to the previous slide again. So I know there is lots of text and the difference is subtle. So if you, in my code that I wrote on Matlab, I just wrote string comp and gen1, gen2, and it's comparing whether the two are the same. And if that's true, then it runs. Another way to write this, if you want to make it explicit, you remember when I run just that, it was returning 1 or 0. So you can say run it only if that's true. That's already what's going to happen. But if you want to say it explicitly, you can add the equal 1. So that means runs only if it's true. And if you want to say run only if it's not true, so run for all the other genes than the one of interest, you can change by putting a 0 here. So it means it's going to run only if that is false. And this being false means that this whole statement, including the equal 0, being true. So actually what's happening is that when I just wrote the way it was written before, so this way, it was like the logical test was, is this true? Are those two equal? While here, the logical test is that value returned by that test equal to 1, or is that value returned by that test equal to 0? Is that clearer? Okay, great. Okay, so now we are moving to functions. So so functions are gonna be useful, as I told you before. If you want to apply the same algorithm to several, for instance, data sets, or to several conditions in which you just slightly change one argument or something. Matlab has I think, a unique way to deal with function. I've not seen that in other coding environments. So what happens with Matlab is that you have to put a function in a dedicated script that is only for that function. And the script has to be named with the name of the function. And so then when you call that script, it's gonna run the function. So it's a bit like, it's a bit picky syntax-wise. You have to follow exactly the way functions are defined, otherwise it won't work. So the way we write it is you have to write function, and then the output that's gonna be returned by your function, then the name you want to give to your function, and then the input or the argument if you're thinking in, in more math term. So they have to be saved in their own file, which gonna be named with the name of the function. So the word here, function name, has to be the same one as here, otherwise it won't work. That's one of the error I see the more often when people try to run that. So for instance, here I created a function. It's gonna return the info on the sequence. So always start with function. That's like a Matlab code to say we're starting a function. That's the output. So that's going to return the info on the sequence I'm interested in. And that's the name of the function, describe sec. And that's the argument I put in my function, or the input sec. Then that's whatever happened in the function. And then that's the output being defined. So with Matlab, what happens? So actually, I already wrote it before, but like if I'm gonna write a second one. For instance, I'm gonna call this one 2, describe sec2. And here, if I try to save it, Matlab is again taking you by the hand and helping you. It's already offering you the name you gave to the function. So I recommend you write the first line that is defining your function. Then you save the file because it will automatically put the right name, and you save, and now you have your function being defined. Okay, so I'm just gonna use this one. So what's happening here, again, that's the output, that's the name of the function, that's the input. So the input is gonna go, so you give your input to the function, it's gonna go in the subsequent code, which here is gonna define the sequence length using the length function applied to your input sec. And then it's gonna generate that output here. So here I use a S print instead of F print because I'm not printing the object, I'm like saving an object that contain a character string. So that's the function sprintf instead of fprintf. And the sentence is the sequence S, which was my input, has that many nucleotide, which is the value I'm calculating here. So there are a few things that are very important. I remind you the name of the file has to be the name of the function. So here and here, it has to be the same thing. You have to have an input that is actually used in your function. So the input here, and that's again a useful trick with Matlab. You can check that there is no typo, you're actually using your input or whatever. Here, it will be highlighted in blue. And you can also check when you define your final output that everything you have, including your output, was actually defined before. So for instance, here we can see sec length was actually defined before. Yeah, so the difference with sprintf and fprintf is with fprintf, I'm displaying something. With sprintf, I'm saving this as an object. So for instance, if I define that as, if I pre-write a sentence, then it's saved as an object, infosec, that is here, and that's an object that I can call again. So it's just because with a function, you need to have an object that is your output, then I use that. Okay, okay, so we're gonna see now how it works to run. So again, I'm gonna clean everything and clear the command window. So the way to run my function, I have to use the name of the function and then give it an argument which corresponds to the input the function is running on. So here it's sec. I know because I read myself that it has to be a string of character. And here I was thinking, a gene sequence. So that's my input here, and that's the function, and I run that, and it executes the function. So you can see I have the output here. One thing you have to be careful with is actually for instance, the sec length, like everything that is defined within the function is not actually gonna pop in your workspace. It happened under the hood, it's not saved. The only thing that's gonna be saved is your output. So that's very practical because it means that everything you do in function, it will run faster. So that's a really quick function to execute. But when you have really long functions that are handling lots of data and generating lots of like intermediate variables, it's not gonna waste time and memory saving those variables, and it's just gonna save the last output you are looking for. So for instance, if I want to give a name to this object, I can also running that way. And you see I created an object. So it's exactly the same thing as if you were using, the function min, which is like the predefined function in Matlab or something like that. And what else do I have to, yeah, you don't like the output, the input here, you can either write it directly here or you can define it before. So for instance, if I write my sec equal that, and then I run the function on my sec, that's gonna return the same result. So this is very useful. For instance, if you have like 10 different sequences, instead of having to write this 10 times, you can you write in one in the function, and then you gave as an input the 10 different sequences you have. Okay, so I remind you the important thing. So first you write the function in a script. It has to be in a script so you can save it as a .m. You make sure your input is like you actually have an input and you use that input in your code. You have the output to be defined too. And yeah, make sure that the name of the function is used as the name of the file, which will happen here on the tab of the script, and also it should appear in your environment, in your current folder, sorry. And you see actually here I have a script, normal script, and here I have a function, and the icon is different. So that's the way, like if you're trying to run a function and it's not working, you can check that it was actually saved as a function, and if not, it's very likely because there's something wrong with that first sentence. So for instance, you either missed the word function or you didn't put the right name. So for instance, if I use that, it says, so I used script, it says execution of the script as a function is not supported, and that's because you can see here it's not a function. It's not saved as a function, it doesn't have the right icon. And then to run the function, you just have to write the name of the function, give it an input in the command window, and that's gonna work. Okay, so now we are going back to the script we wrote before that was looking for a gene of interest in a data set with gene names and level of expression. So just to remind you the context, we had 3 genes with their 3 levels of expressions. We're looking for the level of expression of this specific gene. And so what we did is we made a loop that was looking to all the genes one after the other. So the first one and so on until the last one. And for each of these iterations, we were comparing the name of the gene to the name of the gene we're looking for. And if that was true, so if this condition was returning, if this test was returning 1, they will print that expression. So now we want that as a function. So for instance, if we have it as a function, it means we can really easily adjust it to a new gene of interest, just change the name without having to rewrite the function every time. Or we can also run that function on a different data set than the 3 genes without having to write the function again every time. So to transform this script that we already have as a function, we need those 3 things that I was mentioning before. The name to be right, the output, and the input. So for the name, we're gonna add this, and we're gonna call that function here, I call it print gene of expression. The output, I call it out, and the input, here are the 3 inputs we have. So the 3 inputs we have are the name of the genes here, the level of expression of his gene, and the gene of interest. You don't need that in the function because that's something you're gonna give as input. So it doesn't have to be in the function. That's something you're gonna put later when you call your function. So you can remove those 3 lines. You have to attribute a value to the output. So here, for instance, you can add the level of expression that of the gene you're looking for. So that's what the function will look like. Again, you write function, the output that is later used here, the name of the function, and then your 3 inputs. The inputs are not defined within the function, they're defined before, or I mean when you call the function. So they don't have to be here. Then everything is the same except that now you make sure that you define the output. You have to check that all those inputs that you're using here are actually called, or actually what is important is not really that the input is called. What's important is that every object, variable, whatever that you have in your function needs to be defined somewhere. So either as an input, so that's the case for this one, or as something you calculated within the function. So for instance, here, the select is something I defined within the function. Otherwise, you will try to run the function and you will have an error saying I didn't find that variable that was called in the function. Okay, so here is the function we have. And so now when you want to execute that, so yeah, I insist on that. That's a common error we usually make at that stage. The print gene expression is the name of the function. It needs to be the name of the file with which you save the function. And you can check that it was actually recognized as a function here because we have the symbol, the icon of that file is showing an fx for function, which is different from the script, although both are .m. And then when we want to execute that function, we will need to sorry, I'm showing you all the windows. So I'm gonna clear everything again. If I just run that, so my function is saved. If I just run that, I'm gonna have an error saying I don't know all those variables you're putting as input that don't have any value. So you need to define them. So I'm gonna cheat again and call them from here. So you can do it in different ways. You can either execute this. So I have an issue with my French keyboard and the quotation mark not being the same. Okay, so I have those three functions, so three elements are not defined. So now if I call the function again, the function runs and yeah, it's printing what was so it's printing this, which I can remove or keep actually. So for instance, if I do that, it's not printing the sentence anymore, and it's also returning you the output of the value you are looking for. So here the level of expression of the gene we're looking for. You can also run it by directly writing the value, like instead of defining the values of those variables before, you can also write them directly in here. So that would be the name, that would be the results of the experiment, like the level of expression, and that would be the gene of interest. And so if I run that, that's gonna give me the same result. Are you following so far? Okay. One thing that is useful, I think, when you write function is to, so there are a few things. The first thing is, again, that's something I told you yesterday. If you write the function that is aimed to be used by other people, or is aimed to be used by you in a few months, try to make things as explicit as possible. So for instance, you might want to add some comments saying X1 genes is a cell array with the name of the genes as character and so on. So this way, you know things are kept. You won't have errors, or if you have errors, you know how to solve them easily when you rerun the function in 6 months and you put the wrong value, or you don't know what you're supposed to put anymore. And also, I think I explained that later, but I'm mentioning now. You can use the help function of Matlab, and yeah, it's returning whatever comments you put at the top of your function. So there are very developed help functions for the Matlab function, or help documentation for the Matlab function. So for instance, here that's just for the max function, which is returning the maximum of among values. So you can do the same. Usually you won't have it as defined if it's just for you, but you can do the same thing where you put some comments at the beginning of your function, and you can access those comments easily just by typing help and the name of the function. And yeah, so when I say always expect the uninspected, so for instance, one thing you might want to plan for is if the gene or expression you're looking for doesn't exist, is not in your data set. So for instance, when I'm running my script, here, if I take that again, and instead of looking for that gene BCL2, I'm looking for the gene 6. The way I wrote the function, I added that out no gene found. So if that gene doesn't exist, I have the indication. If I don't have that and I run it that way again, I don't have anything happening. So I'm not sure whether my function actually ran or not. So that's, I always find it a bit confusing. So I like to always have an output. So I added this. And so what happened is that if I put a gene of interest that is not in my data set, then, or actually what happened independently of the value of gene of interest is that when I start running the function, the output will be defined as no gene found. Then it's gonna start the for loop and the if statement. And if that condition is verified, so if we find the gene of interest, the output will be overwritten with that new value, which corresponds to the level of expression. So it's updated to the relevant value. So I won't have that sticking around if I do find the gene, but I'm, my function is running anyway, and I have an output, whatever happens. So I really recommend doing things like that. As I was saying, put comments. So if you use a function later, or if someone else used it, they know what happens, and you can access those comments easily with the help function. Because the one, it's just for the one that are written just after the definition of the function. And okay, that's it for today. So it was better timing than yesterday. Do you have any questions? Okay, I don't see any questions. So yeah, that I think if you think about what we've seen today, so we've seen 3 really important things, and one thing that is more accessory. The 3 really important things I think are the if statement and the for and while loops, and how to define a function. And the more accessory thing is working with LRS. The for, while, and if thing that's very common across all programming language. So if you use other environments, you will also encounter them. The syntax is sometimes a tiny bit different. So for instance, in R, instead of putting end at the end, we just close a bracket that we opened at the beginning or something like that, but the logic is the same. And so the function is if you actually use Matlab, for your research or whatever, that's something you're gonna use very often. It's just so practical to work with function instead of having to write independent scripts for everything all the time. So if there's something you want to, revise after today, I think that's really understanding how function works. And yeah, so remember those things. The 3 elements of a function, it's his name, the inputs and the outputs. And if you understand how those 3 are connected together, you should be able to write any function you want. And within the function, it can be as complicated as needed. As long as those 3 elements are defined, it will run. So you can have hundreds of for loops. It can be a function that takes 3 days to run because there's so many calculations, or it can be something like I wrote that just take half a second. but just that you call all the time, so it's easy to have it defined. Okay. Again, if there is any question, now is the time. Otherwise, you send emails. And I will post the slides, updated slides, and the scripts and the recording today on the drive. So you can check that out whenever needed. And otherwise, I'll see you tomorrow. Bye.
Okay, thank you. Bye-bye.
Bye.